Okay, here we are. Let's make sure my levels are good. Good. Microphone levels look okay on my end, not muted anything. Alright, how you doing? Welcome back to another week of Haskell hacking. We're making arcade games, testing out the waters with making an Asteroids clone. In Haskell, the functional programming language, which I use pretty much almost most of the time, 60% of the time, every time, kind of exclusively on this channel. So we're going to work on today. Last week we just got movement kind of working. So here's what that looks like. Alright, we got a little ship, we turn it around, give it a little thrust. It moves. Boop. It moves that way. It moves that way. Yeah. It turned really fast, but that's pretty cool. So we might want to play around with the ship mechanics and kind of mess around and tweak that. But that's what the game is so far. This week I want to get the ship wrapping around. Alright, so that we don't go off screen like you saw there. And yeah. And then maybe we'll get some pew-pew-pewing happening. And once we have that, we can do the asteroids, scorekeeping, and then like a little polish and touch, and we should have a pretty decent little game going. We'll see if we have to do any like optimization work or any performance work. Like, this is a very, very simple game, so I don't expect to have to, but we'll see. You never know. Once the bullets start flying, the asteroids are everywhere, and we fill up the screen with a whole bunch of rendered entities, maybe we will. You know, because they always say, like, garbage collection, no good for video games, but it depends, as senior developers I want to say. Not that I'm a senior developer, of course. Kind of, I guess. I don't know. Some folks seem to say so. Anywho's, let's not worry about that for now, and let's get to work, shall we? Okay. So let's go into Asteroids, into game. Here we are. So we want to, first order of business, let's get this ship wrapping around the screen. That, I think, is probably going to be the trickiest thing to do. How should we do that? Maybe it won't be so tricky, I'm not sure. It seems like it's going to be tricky, though. Okay, so normally, right, when we have the player's position, right? But the player's position is like the center of that triangle-ish. And like we rotate all of the points around that center dot. Right, let's draw this out a little bit. My little happy pen program. So the question is that when we get to the edge of the screen, what are we going to do? Right? So like, there's our little point, right? And then when we go to, that's the player's position, it's just a point. And when we go to render it, right, we render like a point out here, and then we draw a line, because we draw a line to this point over here, and then we draw this point over here, draw a line to it, and then we draw technically another point on top of this point, we draw a line to that, right? And that's our ship. So far? Alright, so then whenever we apply rotation stuff, we rotate these points around, so on and so forth. But They all rotate around that point. When we get to the edge of the screen, I'd say the edge is like here. All right, we gotta come up with, sorry, Haskell cat's here, coming in my lap. We have to come up with a way of rendering this. Either we gotta wait for all of the points to be off screen before we draw it on the other side, like over here. Otherwise, like I got a point here and a point here. But now, if I try and say, well, if this point is past the screen, then draw it on this side. All right, imagine it's over here now. Well, my drawing function is going to get a little funky, I think. All right. Because now I'm going to draw from here to here a line. And that's going to be no bueno. No good, no good, no likey. Right? And the other thing we could do is if the line is, we could wait until all the points of the ship are no longer on this side of the screen. Right? Give the screen like some maximum, like a buffer. And then once we know all the points are within the buffer zone, right? We draw, we put all the we just transport all the points. If we're traveling along the X-plane along to the other side. So we just like teleport the ship over there. And then it'll look like when it comes off the screen that it's, you know, traveled across, maybe. You'll get an instant where, of course, it's not on screen at all, but it should come across the other side. Which probably might be the way to go. So I'm gonna clear the screen here. We'll get some code. See how that looks. Okay. So our position. So this is our update loop for our physics. We could do it in the game loop, the outer loop. And if we do it here, now we need to, I think we need to do it in the physics loop because we might still be in the middle of doing those updates if we're traveling really fast. So yeah, in that case, we have the position here. The total size of our ship is the position, well, size times 2, essentially, roughly. It's a little thinner, but like lengthwise, the triangle is, we use size times 2, I believe. If I'm not mistaken when we're rendering it. So our buffer zone should be about that. So then we just have to check if our position is like on the X plane. We'll check it in twice. We'll do X and Y, I guess. It'll be a little bit tricky maybe with the corner. All right, that's our position. And we move. Our next position is like here. All right. And it's enough XY and enough Y that we're inside the buffer zone, but which, like, where do we render that? Maybe we could just flip the modulo the numbers around. Yeah, something like that. So that basically we transport it over to the opposite corner, and this the opposite side of wherever we happen to detect this situation. Okay. So let's do that with, what do we need? A function. Off-screen position, torus position, reposition, wrap position. So wrap torus would be a function that would take our position, and it's going to need, well, it's going to need more than our position. It's going to need the position, our size, and the bounds of the screen that we want to be in, or that we want to wrap around, I guess. So let's say position, game state, layer size, and the bounds of our screen that we're rendering to. Let's see. I don't set that in the window config. Renderer. I guess we use the default window size, whatever that is, like 800 by 600 or something. We can probably query for that. Let's pull up our documentation. What am I looking for? Window. There we go. Yes, it's 800 by 600, the initial size. I don't think we have resizing going on this. It's easier not to, so let's just forget that. So we can just hard code it. We know what it is supposed to be. Okay, so we can hardcode that inside wrap torus, I suppose, for now. And we just have to define it. Oh, somebody made a suggestion that clamp is actually just min. And that's probably right. So thanks YouTube watcher and subscriber. We should fix that too. Wrap torus. So the v2 of floats for our position. The I guess int for our size, and we return a v2 float. Okie doke. Okie doke. V2, position X, position Y, size. Okay, so how are we going to do this? So I guess we can check X first, and then do Y, and that'll be that. So we know we're going to return a V2. I'll put it like this. No, we don't need this. Yeah. It should be fine just like this. Okay, so the X part. All right, we have PX and we have size, and we know that the width is 800. So we got to wrap X. And then we got to wrap Y. That's probably a little bit too far. That's probably okay, yeah. We're gonna float. Int. Float. And wrap Y. And we just have, let's see, we have to compare X and S with 800. So if X plus the size is greater than, let's use guard. So if X plus X is greater than the 800, right? So it'd be the position. So like this is, sorry, this is 800 here, 800, and our position, say right here, plus our size, right, is greater than that. Maybe it should be minus our size, because we actually want it to be this side. Yeah, I think that's the way we should go. Alright, so if our position minus our size, this point here, is greater than 800. That means we're all the way over off the screen, and we should flip this over to the other side. So we'll flip the sign on this. All right, then we should do that. Otherwise, it's just X. All right, we don't have to wrap it around. S is a different type, so I have to do from integral to convert it explicitly. Okay, and now we can do 800. Oh. X minus 800 minus S. All right, so that'll be So if we have our position, we detect our positions here, right? X minus S is over here. Right, this is 800, and this is like 801. Right. Then we subtract 800 from that, from there here, and this distance. Right, so if this was our size is 10, this is, so this would be 811. Right, 11. This would be 801. 1. Alright, so then we plug that in here. 811, so that'd be 11 minus 10, so that'd be 1. So that would actually still be on screen. I gotta go into the buffer zone. So I actually want to add S to 800, I think. I think that's what I want. Otherwise, just X. And I think that would make, so if it was 811, 800 plus S, if our size is 10, would make that 810. So that would still be 1. And so just as we're getting off the screen, we'll be just appearing, at this point, we'll be just appearing like 1 on the screen. Another thing we could do is we could move the point to 0 and subtract the width from it, so that it would be kind of the same offset on this side as this side. Yeah, that seems more reasonable. Or just negative S. Let's try that, see how that works. And similar for Y, would be basically the same thing, only on the Y-axis. And 800 will be 600. Okay, let's clear my fun little drawing. Let's, do we have any type errors to fix? Just here. Oh, it's a C-int for game state player size. Is there a function we can use here to convert that to an int from integral? And py is not used. Oops. That caught an error for us. Thank you, warning. Okay, now we're good. No warnings, no errors. Let's get our build going. See how we did. Okay. Let's try the x-axis. Doesn't work that way. Try the other edge. Okay, it works that way. I think when we're traveling the other direction, we have to flip signs around to make that work. Our formula doesn't work here for the other direction where x is 0 or less than. So we have to add a case for that. Okay, so where x plus from integral of s is less than 0, then we go from integral s. Or no, we got to do 800 plus. And we had the same case for y. So we change the x's to x, y, and this to 600. Okay, rebuild. We should be good to go. How? Okay, we're good there. Let's go the other direction. How? We're good there. Let's go vertical. Sweet. Max thrusters engaged. So we're continuously adding thrust here. So this is where we need our max acceleration to kick in. That produces a nice trippy visual effect. See if I can get it slowed down enough. Ooh. Thrust in the opposite direction. Okay, that works pretty good. Pretty well. There we go. All right, let's commit it. Torus wrapping. Torus field? I don't know what to call it. Screen wrapping. All right. So the player ship phase on the screen and wraps around at the edges. In other words, around a 2D torus. Okay, cool. So clamp, as somebody mentioned in the YouTube comments, is probably just min. Let's see if we can just replace that. Probably is. So we can get rid of that. Small little refactor we can pop in there. Replace clamp with min. A function by any other name is still a function. Right? Cool. All right, so acceleration, we need to max that out. Oh, except we messed this up. Here's the only other use of clamp we had, so fix that. Okay, and okay, acceleration. Do we have a max acceleration variable? Yes, we do. So what we'll do, we set it default 3.0. Okay, so we'll do a min on that as well when we update the acceleration for the next state. We'll just take the min of the new computed acceleration or the max acceleration. Game state player max acceleration. Probably because they're two different types, maybe, is what I suspect that is. Yes, okay. Right. So our acceleration is stored as a vector. So that min doesn't make sense there. Unless we can convert it to a float value, or we can clamp the components of our acceleration vector. Like, choose a min on that. But what an appropriate value for that would be, I'm going to need to just print out some of those values and see. That's what I'm going to do. And do that here. Because we reach max acceleration. That's all fine and dandy. Or no, thrust. Oh, this is supposed to be doing a min on the max acceleration for each component. That doesn't work. Or our values are just getting, like 3.0 is just too high of a value. That could be the other thing. So yes, let's work on this and print it out as we go. So we'll just debug.trace here. And we'll just show acceleration. It's a little messy. Don't mind the code. We'll get rid of that. I like to leave the debugs kind of messy too sometimes because it reminds me that they're there. I don't forget to take them out by accident. There we go. Okay. So our max acceleration 3.0. We're getting fast, but it's just staying at 3. Even though visually we're moving quite fast now. And then if I turn my ship around, apply in the other direction, we get about -3. right? And still working in the Y direction as well. So the min is working on it. Must be my understanding of the formula is a little bit off. And where we should apply our... Maybe it's velocity we need to apply our min on. Okay. That seems reasonable. Probably what it is. It's been a while since I've done this kind of stuff. Fun. So, let's get rid of that. Look at our velocity. That's probably the component we need to worry about here. So let's put. I think the type of min here is velocity is going to be a float value, scalar, and I'm just going to put game state. I might rename it to max velocity, but I'm going to put the game state player max acceleration value in there. Now they are to. Oh, it is a V2 as well. Okay. So let me try this way. I'll pull apart the calculated Vx and Vy components, and I'll construct a new V2 where I can min each one with the max I want. And Vy. Pull this over a little bit. It's not going to work formatting wise. There we go. Okay. Seems happy. Okay. Alright, there we go. A little wonky. Something we can max our velocity vector a little bit appropriately, then we should be able to. Yeah, it's not quite working the way I want it to. It feels a little wonky. But we're on the right path, at least. Cool, so I think what we want is to... I think it's... Hopefully I got the terminology right. Normalizing a vector. Hopefully that's correct. This isn't correct. This is wrong, but it just tells me I'm on the right track here. So yeah, that turns it into a unit vector. We don't exactly want that. We just want to keep the vector at a certain magnitude. So like how to cap a vector at a magnitude. divide by the normal vector. So you have a vector of unit length, and then multiply the minimum of the original normal and your maximum. Cool. I think that's how my math textbooks say it. Should be done. I agree. We get the length of it. If it's the length is greater than our maximum, then we get a multiplier. Okay. Otherwise, the multiplier is 1, which is anything multiplied by 1. That's the unit right? The unit value there, so it should change nothing. And then that. Okay. Scooby-Doo. So we need like a clamp vector function. Does actually our linear library have one maybe? Before I go and write it. Do lerp lift to negated. No. Okay, so we're gonna have to write it. Which is no problem, it's not a terribly big function, it's fine. Yeah, let's create a little vector module for ourselves. Asteroids linear vector dot this. I'll do. We'll create a where, and we'll import linear. And we want a function, clamp vector. So take a v2 of some a, some maximum. Some value for max m or maximum. Which I guess will have to be the same type as our components. So a. And we'll produce a v2 of a. We'll just leave that undefined for now. Go back to our game module. We'll import it here. Asteroids.linear.vector. And then in our code here, we don't have to do that. We can just get rid of this. And that vector. And then we give it our velocity and a scalar value to clamp by. Just say 4.9. Those are 9. That should type check in this module, except for the undefined. Okay, v max. Okay, so the length is the square root of our components to the power of sum to the power 2. Okay. square root. Pull this apart, v2 vx and vy, just like that. Vx power 2. I don't think we have that operator in Haskell. Not a tuple. What am I doing? Okay, so we don't know anything about A, so we don't know that we can use square root on it. We have to put some kind of restriction on A. Numeric should be good enough to use square root. What happened to our tunes? Sorry, Pretzel's taking a break here, apparently. Let's see what we can find. Stations. There we go. This one. Okay, hopefully that's good. Let's see. Oh, this is just our return value. Yeah, we're just let's bind this to something. Length equal. Yeah, bump. Oh, it needs floating A. Okay. We can't just use num A to use square root, because that's going to reduce floating point values. Or it takes floating point values. I'm also curious if that's actually a thing. Let me put this as undefined for a second. Get up our REPL. That just takes a floating as well. Well, that'll probably be fine enough for our own purposes, I guess. So instead of num A, let's make it floating A. Now what's the problem here? Oh, yeah, okay. Yeah, square root takes one value. We gotta sum these together. Okay, and we just have to fill this hole in. So the next part is we check the length if it's greater than our max. And our multiplier. Okay, so then let's also create our mults. M. I'll write it all out. Right. Len is greater than Vmax. Otherwise, 1.0. Floating doesn't imply ord A? Weird. Okay. And max M divided by length. So our Vmax divided by len. And then our final formula becomes a V2 and we multiply each component by the multiplier. Okay. So Vx. So we're going to have to use, multiply by multiplier. And Vy. Multiplier. Okay, that should be good. Asteroids game. We use it here. Everything compiles. Well, let's test it out. Let's take it for a test drive. Okay. We're moving. Okay. I think we just need a higher max value there. So 4.9, I think is what I fingered there. Let's try 10. Kinda works. What feels weird and janky about it, though, which is hard to show on screen, is that when I press the button, like, we're coasting along here, and, like, we slow down, we speed back up, and it kind of, like, jumps into the max. Maybe we just need a higher max. Let's try something like much higher, like 49. That's better. Yeah, so it just felt like our max velocity wasn't quite as high as our thrust allows, and so it was just kind of like just jumping in. It felt like it was hitting a wall, like we were just going and then whoa, like into a jar of jam. You ever seen that cool space show? What was it called? Oh, it was on Amazon. I can't remember the name of it. I love that show though. But they go through this porthole, this like wormhole type thing, and to like another dimension of space. But as soon as they hit it, everything slows down. That's what it felt like. But now that our max velocity vector is much higher than like kind of that ramp towards our max thrust, And it feels a lot better here. And I think we'll be able to take off the min on the max acceleration. I have a feeling that is a thing we will be able to remove. But I'm going to commit what we have here so far, since it kind of works pretty well. So add that file, and these changes. So clamp player velocity vector. Limits the max speed the player can reach. And yeah, let's remove this. Just get rid of you. I'm still holding down the thrust. Okay, and that's working better. That's nice. And actually, we are getting. I don't know if you can see it with the stream compression and all that, but we are getting a little bit of jitter. Hard for me to say at this point if it's just like the setup I have going right now with streaming and everything else, or if we're having like actual frame rate problems. But it does feel at least smooth and consistent. And so yeah, there we go. Bam, bam, starting to feel like asteroids. Cool. Get rid of that. And we could probably get rid of that value out of the state as well. The max acceleration value. Or we can turn it into max speed, velocity. Yeah, let's do that. Do a mass replace. Game state player max speed, max velocity. $49 felt like a good default number there. And we'll remove this magic number here. And there we go. Yeehaw. Cool. Okay. Rename game state. Oh, sorry. We'll just say rename max acceleration to max velocity. Let's clean up these commits and squash those in. Cool. All right, looking good. What time do we got here? Plenty of time. Okay, what should we tackle next? Well, this is probably something we're gonna have to do at some point anyway. Why don't we just take a little bit of time to add some strictness to our game state. Well, no, actually, it's not a good idea. Because we need to be able to measure it first before we start cutting. So I need some kind of FPS timer to see if we actually, any of our changes are going to have any real effect. If we even have a problem to begin with, and like I said, it's not part of our setup here. Okay. How to add an FPS timer. Do we have one in SDL? Timer. No, not timers necessarily. Okay. So this returns the count per second of the high resolution timer. And our performance counter function gets the current value of it. Yeah, so this is, usually the one used for profiling. The counter value is really meaningful relative to each other. So we check what we had last frame, we get what we have now in actuality, and we can see how long we're taking per frame. And then we can add those up and see how many frames we're getting. We're going to hopefully extrapolate how many frames we're getting per second, a frames per second counter, right? I just want to display. I think that's how we would do it. With the SDLs. Yeah, new time minus old time. Yeah, that's wrong. One divided by I don't think so. Surfaces are the old software rendering buffers, if I remember my SDL history correctly. Textures. We might be able to do something with the texture. Text. Display. Now let's just do it the cheap way for now. It might have some negligible effect on our FPS. So I have to take that into account a little bit. Maybe we debug, it won't be so bad. Still will be. Qualified. Debug, trace. Let's debug. Yes. We'll do it here after we've rendered. Pretty good. See if we get any. It'd be nice if I could capture some of these actual samples. We'll figure that out. We'll figure that out. We'll get a proper FPS counter displaying in our render. Yes. But for now, yeah, like we're a few hundred. We do get these dips. 78, 81, 46, 75, 73. Fairly sporadic, looks like. So it could be that we're seeing some garbage collection action happening. And that could be what's going on there, potentially, possibly. So it'll be hard to say. Actually, I don't want to commit that with the debug trace in there. Let's add it to the game state so that at least it's easy to add it, and when I find a way to render it, or if we can find a way to render it easily, then we'll do that. So let's go to game state. I'll add the field game state FPS. Float. Oops. There we go. And let's like 0, initialize that. And then when we calculate FPS, we can just pop it in here. Game state Now let's pop in game state FPS. Okay, so at least it'll make it easier to print out when I want to. So commit that. Okay, and down. Okay, so game state. Let's just add bang patterns. All right, and then let's make the fields of our game state all strict. Values. See if that has an effect on our FPS here. It's probably a faster way for me to do this, but I'm doing it manually. So there you go. Oh wait, we can't have it on the V2 like that. All right, I think that's what that type error is. I don't think we can do it that way. We have to do it on the... Oh, we just have to wrap it? Okay. That's the problem. So all this is really doing is forcing these values. They're not... allocated as thunks on the stack there, waiting to be called when they're used in the program. So they're always computed there. Which is a kind of a light way of checking, of just adding a little bit of strictness in your data, tends to somewhat improve the performance of most Haskell, or a fair number of Haskell programs. Sorry, that was not the right thing. I wanted to do on the definition. It's not like magic soy sauce, but it kind of does work most of the time for most things, I would say. I certainly found that when I was working on the Postgres library that we wrote on the stream here. We kind of added just strict data to everything, and it made everything. It used a lot. The library started using a lot less memory right off the bat. All right, so we're moving, and we're moving. Woo. Not really noticing any dips or flips. Although I'm noticing my Haskell cat here getting in the way. So we'll have to check the FPS again. But I'm going to be a little bit suspicious of the FPS in this case, just because, like, when we're printing it out as we are here, like, that has to go to the console, that has a non-negligible cost. So it's not an accurate read, is all I'm saying. Yes, let's not do it in the update loop, let's do it here. We'll have to import that, of course. Debug.trace. Oh, wow. Like that. still getting little dips here and there. All the way down to 60. Now this isn't too bad. This isn't a sign of anything really. It doesn't look like we've changed a whole lot by doing this. Yeah, so it's not really doing a whole lot for us, I think. So when this doesn't work and doesn't have like an impact, again, this is not being terribly accurate, a terribly accurate way of measuring the actual FPS that we're getting. The next thing we need to think about is can we not keep constructing the state. Right, like it's hard to tell if any kind of like optimizations are going to kick in where like GHC can figure out how to like what we're doing with this recursive loop here, like game state to game state, and if it is smart enough to, or if there's anything we can do there. If it's not doing anything here, like maybe it's not mutating something in place, that could be. Right, we can fix that. Right, we can wrap the game state in an IO ref, right, and then we only have one copy of it, and so we're not garbage collecting anything extra when we do that until we terminate the program and the IO ref goes out of scope. Right, we can mutate it. But that's going to require us to change a little bit the structure of our program here in our loop, and that sort of stuff. I'm not too worried about it right now. We don't have a whole lot of time, so I don't want to dig into that. So let's see if we can implement maybe our first little pew or something. So I'll go ahead and commit the bang patterns, even though it's not really... Actually, if it's not really doing anything, let's not commit it. Let's forget about it. Let's just get back on that. So it looks like it's Haskell like is going to need a little extra work to get like an arcade-style game to feel good and smooth and have like a stable frame rate. Which is all fixable and possible, so we'll have to keep an eye on that. Well, that'll be a future stream. We'll do that maybe next week or something. Okay, game. So this will probably stress the system a little, even a little more. Maybe reveal if we have an unstable performance problem. So the pew, the bullets, right? In order to render them, we have to have their positions stored somehow. Player bullets, we call them. Now, where do we store them as, right? They're going to be v2 of positions, or they could be especially like constructed vector. Like they can either be vectors of v2s, or we can make them arrays, and we can encode them as arrays, and just update the array in a certain pattern, so we can like kind of keep all that data located very, very close together in a very compact structure. Right, the simplest lazy way would just be like v2 float like this. And then we have this list of bullets, and then we can just iterate the list on every frame and update their positions based on their the way bullets are supposed to behave, and that's that. There's two schools of thought here. One, right, we can make it work first, right? We can make it right and then make it fast. And there's the other school of thought is, well, don't choose the obviously bad data structure up front. That's like, instead of the off-thrown amount round maximum, you should avoid premature optimization, you know, which isn't the whole quote. The whole quote's much more interesting than that. But there's premature pessimization as well, right? There's this idea that if you choose a structure like this, it's harder to change later on, and you know it has bad performance. And so, of course, you're going to have a bad performance. And the more stuff you build on top of this, the harder it is to change. So you're pessimizing your performance. You're making it bad by these early decisions. So the key, I find, is somewhere in the middle. There's a balance to be struck, where when you're prototyping and hacking stuff and you just want to get it to work, you don't really care about performance. Making something good, and just use the first thing that's easiest to use. It is code. It can be changed and it can be made faster later, as long as the delta between when you decide to make it fast and when you made this early decision isn't too wide. So I think we'll be fine here. Let's stick with just the lists for now, even though I know it's gonna not be good. It's just going to be bad. And we might see that FPS counter get even worse. Okay. That's it. The state's there. Yep, things are looking good. And now we need to listen to a new button for the firing. So we'll add a new key. And we have to do that here. We want key fired. Actually, let's go to our button state stuff. So we'll add a new button state for button state fire. And that'll be in the release state initially. Okay, and then we have to test all of our SDL events. We have to test a new SDL event for the fire key. Let's make it like spacebar, it's easiest. Space press event. This keyboard key event SDL.pressed key code space. I'm not sure what the key code is. Is space released. Maybe it's right. And space release. Space up is the convention. Okay, that's a little weird. And fire button state. Space is pressed. Key release. Fire. Otherwise, space up and key down. Yeah, really want to refactor this. Button state fire, of game state, button state, key release. Otherwise, and then we have to use it. So we got a new button for firing. That should work just fine. And now when we update and we detect that happening, we should... Ooh. Well, if we do it in this update loop and we just detect that the key is down, right? And we add a bullet to that list of bullets, it's going to add them as really, really fast, right? Because we're going to be doing this update loop several times inside of the main loop, and we're integrating the physics in small time steps. So we're going to kind of want to have like a delay between how fast we can add bullets. But let's just check that our key press works. We can do that with some debugging. And we'll just show fire button state. So there, it's a key release, it's key press, it's a key release, press. Oh, I had it focusing. There we go. Now it's key down. Oh, no, that's wrong. Released. And that's why we gotta check it. And that's why refactoring this would be great. Avoid bugs like that. Okay, so now it should work. Now, yeah, I'm holding down space, it's only key down. Now it's key release. Now it's key down. Okay, so that works. Get rid of that. Okay. So we need like a accumulator for our bullet time. And once that accumulator fills up, and reaches some maximum value, we can add a new bullet to the list and reset the accumulator to 0. And that'll give us the effect of, like, pew, 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 not brrr, until it's as quickly as it could possibly do it, right? Yeah, so let's see. A couple more variables. Game states, player. Let's get rid of the player namespace. Bullets. Bullets. Accumulator, accum time. Timer. I gotta float. Game state, bullet, time max. Float as well. And the amount of delta that we're gonna no, we'll add the delta time to it. Yeah, I think that'll guess what we want. And we're gonna add the default values for those to initialize them. Game state bullet timer will start off at 0.0. And bullet time max. This will be in. What are we storing the delta time? I think we're at, yeah, it'll be a float as well. Accumulator, it's going to be in like fractions of a frame, fractions of a second. So let's say like, let's just start with 1.0. I think that means roughly 1 per second. Okay, so in our update loop now, we have to check on the bullet accumulator. We have to add delta to it. Game state bullet timer plus delta. We might want to have a variable for the speed. Like delta is going to be a constant value, right? So it's going to be increased by 0.1, like whatever our time slice is that we're working on here. We might want to be faster or slower, so we might want a variable for that. Let's just see how this works for now. Timer and what was the other thing? If it reaches the max, we actually want the next state of bullet timer to be 0. So if oh, we can do that up here. We'll just do a bullet timer here. Yeah. Bullet timer here, and we'll use a guard. So in the case where game state bullet timer plus delta is less than gain bait bullet timer max, and then it should be this. Otherwise, it should be 0. Time max. Okay. I feel like it should be timer max. And so that's a bullet timer. And so now the bullets. We add a new bullet when the bullet timer. When the button is pressed, and the bullet timer is 0. We can add a bullet, and we're good to go. Otherwise, we're going to increment the bullet timer, and we're not going to add a bullet to the thing. We're just going to increment the bullet timer. I just want to check the timing on this without having to get into the list stuff. So let's just add a debug here. We'll conditionally print if bullet timer people actually no, this is going to always increase bullet timer. This is going to increase bullet timer always, constantly. We only want to increase the bullet timer when the key press is down and the fire button's down, and yeah, only when it's held down. Right, so this is kind of another condition for the bullet timer to increase. Key down. Drop this in some parentheses, and then we can do and here. Both of these things have to be true. Key down for button state fire of the game state button state. Oh, I guess we don't need the parentheses. I was just being a little paranoid there. Thank you. Maybe I need parentheses around this cat over here. Oh, it just wants me to move the brackets here. Oh, button stayed down. No, it's fire. It's fire is the one I want. Fire, key down, button state fire. What the heck am I listening? I must be getting stream brains. We're getting to the end here. Couldn't match expected type key state with actual type. Bool. That was just my problem there. I was just being overly eager with the apply operator there. Dollar sign or whatever you want to call it. So if the key down, button state, the key is down for the fire button. And we can increase the timer, so we haven't reached the max yet. Then we increase the bullet timer. Otherwise we reset it to 0. So the effect here should be like when I'm holding it down each frame, this will increase and increase and increase and increase. Right? And the only other time it'll set to 0 is, let's see, if one side of this is false. So if we go over the max time, we set it to 0. Right, and the other side, the other case it can be is when this key is no longer down. Right, it will also go to the otherwise branch. So our bullet timer will be set to 0 when I release the space key, and if we reach the max time. So that's good, because when I release the space key and I press it again, I kind of want to launch a bullet and then have the timer accumulate the time until I can launch another one. All right. Cool. So now I should be able to with fire. I'm just going to create a little temporary variable to test this out, but should fire would be like if bullet timer is equal to 0, then fire, else the empty string. Yeah, and then I'll just print that in my debugger here. Debug trace should fire. Okay, so hopefully this all comes together. That'll be a nice cap to the stream. All right, it's always printing fire. Okay, but here it's actually like the timer's accumulating. It's just when I let go, it's always on fire. So that's because we don't. Why is that? I think that's because, my theory is that's because our should fire is if bullet timer is 0, which if the key is not held down, that will always be true. So we just need to check. Our formula really should be key down, button state fire, game state, button state, and the timer to 0. Then we should be fire, 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 and if I'm not holding it down, it should print nothing. Right. So it's printing nothing, but if I hold down space, yeah, we get this kind of spaced out fire, 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 fire. Which is nice. Pew, 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 pew. fairly regular. Yeah, that should be regular. So that's good. Yeah, so that works. That's going to work for us when we can add bullets, and then we can render the current state of them. So that's our condition. Should fire. Bullets. The next state of the bullets list. If this condition is true, then we want to append. We want to take the current list of bullets and append a bullet to it, or prepend it. Doesn't really matter. We're gonna all process them in a single frame at once together. So the ordering really isn't a huge deal, but basically we would cons it onto the front of it since we're using a list structure for really dumb reasons. We should add one to it, right? So bullets. Should be this, except not strings. Okay. So bullets, if this is true, then we'll add a bullet to the list, a v2 of something, cons onto the game state bullets. Otherwise, just game state bullets. Doesn't change. Oops. We get rid of the debug trace here, and game state bullets equals bullets. So what to put in there? We could just make it the position of the player offset by some amount. Or we just use the position of the player for now. Just to see it work. Okay, so then after we render this, after we get out of state here, let's add our debug back to render that out. Do it here. Trace, bullets, show, game states, bullets, state prime. Here, nothing. Oh, I must be using, oh, right. I'm using a record wildcards in here, which is super annoying. This is going to be a temporary hack. I want to create a function here. Can't do it. Wow, how do I get around this? It's so annoying. Oh, burns me a little bit. Okay. What else can I can do? I could do a function different scope. Let's call it the foo function. Game state bullets is the function I want. I'm going to ignore those warnings. Don't worry about them. All right, and so we added all those bullets. And the list is growing at our kind of like tick, 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 tick rate. Right. So there'd be all the positions of the bullets. Now, of course, we'd have to transform the position of the bullet initially, so it kind of appears like it's coming out of the front of our ship and all that stuff, but we're out of time. So I'm going to commit what we have roughly, except the debug stuff. I'm going to get rid of that. But I think everything else is fine. We'll get rid of the debug import. And we'll create a commit for that. Alright, still files, we're good. Okay. Cool. Bang. Add fire button. And basic bullet state. This is a work in progress still, though. No. We'll do as if we'll commit. That's fine. We don't render bullets or handle limited amounts of bullets yet. So be careful. We're still in development here. Okay, I think that commit history looks pretty decent. Let's push it up. So if this is your first time tuning into my stream here, welcome. Thank you for watching. You can find all the code for this project on GitHub. I'm Agent Ultra in most places, GitHub included. And this is under Asteroids. Asteroids. So this is where all the code is. We just pushed it up, so there we go. And you can check out the game there, build it for yourself, see if you can extend it, do what you want with it. It's all good. It's all open source. So you can follow me on the Fediverse at Agent Ultra. I'm basically parking my Twitter feed. So if you follow me there, you won't see many updates from me. I'm just parking it just because like the operational security of everything that's going on there is not great, and I don't trust that they can keep things going properly over there for now. So, and because I just don't like what's happening there. So less stress in my life. It's all good. Anyway, you can follow me here. You can follow me on GitHub. And of course, here on Twitch. So if you subscribe and follow and all that stuff, you'll get notifications when I go live. I do these streams about once a week on Tuesday evenings, about 10 after 8 in the Eastern time zone. And sometimes I do surprise streams. I do streams whenever, once in a while. So if you want to get notified of those, follow along. Otherwise, that's my schedule. And thanks for tuning in. May all your monads be free. May your types always check. And we'll see you next week. Take it easy.